Hello, everyone. So first of all, I'm Mark. I'm a recovering zombie tester, and I'm getting better every day. I am excited to be here, very excited. I am nervous. There's a lot of you. I'm a little bit sleepy, because Source Labs, that's your fault. And also a little bit perplexed as to why I'm here, because I'm here to kind of seduce you away from WebDriver. I'm here to bring you to the dark side of HTTP and working with APIs and REST. There's going to be some live demos in this talk, and yeah, show you some exercises. So when I think about test automation at the moment, when I think about how teams are working with tools, this quote keeps coming into my mind. Sort of, if the only tool you have is a hammer, you treat everything as if it was a nail. Tools bias us in the way that we work. You know, we choose a tool and it encourages us to work in a different way, or certain ways. But when designing checks, you want to make sure that what you're delivering is something that is targeted, reliable, informative, maintainable, and speedy. And if we dive into tools too quickly, we can sacrifice some of those things, because we might solve the problem that we're trying to solve, but we might do it in a way that might prove to be a headache for us. It might actually create more work for us. It might frustrate us. So I'm going to demonstrate how I have a check that I want to show you, and I'm going to show you how I could change that check using HTTP to actually improve my check, maybe make it a little bit faster, we'll see. I'm hoping the internet works. But still keeping the value of that original check, still keeping that assertions. So all of this is online. I've got 3 different exercises or tasks or activities that I want to show you. And what I've tried to do is I've tried to assign a commit to each of these activities. So at any point, feel free to pull down this code. Excuse me. Pull down the code and just change the commits, and you'll find out a little bit more. So I'm going to give you sort of a brief introduction, but there's more to this. And I'm going to be using the sacred model that Richard Bradshaw posed earlier. Who here was for Richard's talk? Excellent. Showing that my zombie joke didn't land that well, even though you knew what I was talking about. For those that missed it, by all means, check it out on YouTube. It's a great talk. But I want to just briefly introduce it as state management. We're thinking about data and how we set up data, how we manage the state of our browsers, our microservices, and configuration. Algorithm, I see it as sort of the steps that we have to take, the workflow that we take to the codified oracle, which covers your assertions or your diffing, depending on how you're doing your testing within your checks. Reporting, I feel, speaks for itself. Who, how, where, reporting. Execution, parallel, in a pipeline, in the cloud, on your machine. And then deterministic, which I agree is the most important factor in this, that we want to make sure that we have checks that are not variable, are not flaky. Although I am a big fan of sausage rolls as well. Let me show you my check on my laptop, and I'm hoping that you can all see the screen. Is that nice and clear for everyone? All good? Excellent, right. Okay, so I'm going to run this, and I'm hoping this will run, and as it's running, I'm going to talk through it very quickly. So, first of all, I'm working with Bugzilla, just because that's a tool that I've worked with before for sort of demos. I'm navigating to it. I'm then clicking a login link at the top, filling in some login details. Then I'm logged in. Then I enter a bug by going to the enter bug page. So I'm looking up all these different values and filling them in. And then I'm submitting that bug. Then if we sort of scroll down a little bit here, there we go. I'm then having to navigate to that bug that I've created. So I'm going to a component page, clicking on a component, which gives me a list of bugs tied to that component, and then I'm clicking on the most recent bug to load it up, pull information off, and do an assertion on it. So at the moment we can see this is running at, wowza, 19 seconds. Whew, nearly 20 seconds. So what I can do is I can take something like the sacred model and I can apply it to my check. And actually what I can do is I can identify different activities that are occurring in my check. So I can see that the login process is state management. I'm changing the state of the browser. And then with the bug, creating the bug, that's state management as well. I have algorithm because I'm moving through these different steps before I then go to codified Oracle where I'm actually running my assertion. So this is what I'm going to do. I'm going to update this check. I'm going to live update it because, I like to play it dangerously. And I'm going to change these state managements in this algorithm, but still keep the core of that codified Oracle and keep the value from it. So let's start with creating the bug. So I've identified there's a big old chunk of this where I'm filling in a bunch of fields to fill in a bug. So I'll explore my product, I'll explore my application. That might actually be talking to my developers and thinking about things like testability and asking how can we make this more testable. And what I've done is I've discovered that there is an API for Bugzilla, and I can create bugs via its API. So I take a tool like Postman. Other HTTP clients are available. And I work within Postman to identify what the HTTP request is, what is required. So I can see that it's a post, this is the URI, this is the sort of the endpoint. It's got some questionable security around using query strings for password and username, which is terrifying. And I can also see that I've got headers as well. So, sorry, not headers, body. So I can see that I'm providing the same values as I was within my UI check, but I'm doing it now via HTTP. And also there are headers that I need to think about as well. So I've identified all those sort of requirements. I can then sort of drop them into my framework. So I'm going to do that right now. So first of all, I'll comment out this enter bug page because I don't need that anymore. And because I'm creating some data up front, because it's important to me to make sure I have this bug up front, I'm going to stick this in a before hook. Because I might want to use it later if I have multiple different checks. So, do public void, create data. I apologize to those who are not Java users or developers or testers. This approach can be applied across all languages. OK, so I'm going to be very super lazy very quickly. And I'm just going to copy in some code because you don't really want to see me write loads of boilerplate. OK, so let's import all that. Brilliant, so that's running. So I will run that now, and I will explain what's going on here. Let's do a bit better of a zoom in there. There we go. So I'm doing two things here. First of all, I have a model of the payload, or the content that I want to create in my post request. So I have a model called bug payload. And what I can do is I can apply a bunch of values to it. So I'm using the constructor, providing a bunch of values, and it creates my payload. I then have an HTTP library that I've created within my architecture. And this one's called postbug. And if we look here, we can see I'm using rest assured. And rest assured is basically I'm setting the content type, I'm setting the body, dropping the payload in, and then I'm making the request. So if we look now, I'm at 11.7 seconds. So I've shaved off, 8 seconds already? Check is still running, still passing, still giving me the value that I initially wanted. So I'll remove this part here. And let's go back to my slides. So I want to talk a little bit more about how I structure my API architecture. And this might be for an API checking framework that's architecture in its own right, or if I want to bring this into something which is sharing HTTP and WebDriver methods and behavior. First of all, I'm going to remove that cursor because that's annoying. So if we're working with REST, we're working with resources. So what I will have is a package, a folder, a module, depending on whatever language you're working with. I'll have an area in which I'll keep all of my HTTP requests. And I will group those HTTP requests based on the resource that's available to them. So bug and product are two resources within Bugzilla. So I will create a class, for example, and a bunch of methods in there, and each method is related to a specific request that I want to make. Next, I do something similar with the payloads. So I create an area, package, folder, module, whatever, and all of my models for all the payloads that I need to create live within there. And again, I try and keep them separate, distinct, so I know what's required for my bugs and what's required for my products. Excuse me. I will keep request models in there and response models because we retrieve payloads back in responses as well. Then I'll tie those all together, and all of that gets run in the check. So I chose this approach, and it was heavily influenced by working with WebDriver and the page object model, and the ideas behind that. We want to keep it dry. We want to keep it in a state that I only need to update one thing, and it propagates across my checks. So just like we update a selector, I would update an endpoint to its new URI, and away I go. So this design approach, this model, whatever you want to call it, actually exists on GitHub. And this is myself and a bunch of other contributors. We've taken these design patterns, and we've actually tried to apply it across lots of different languages. We have Java, Ruby, JavaScript, and Python and C# in there. So feel free to pull it down, have a play with it, and contribute as well. That'd be great. Now, I'm using APIs. I'm using my product's API to create data. So some might be feeling dog fooding. That's a bit worrying, using your own product to test it. Well, there's two ways in which I might approach this issue. The first of all is I might have a pipeline. So I might have some API checks that are very much specifically targeted on that creating that bug endpoint. And I'll try and sort of check it, test it in lots of different ways to ensure that I feel comfortable that it's robust enough that I can use it later on. So there's an element of trust that's going along your pipeline. However, if you don't have that or you don't feel comfortable doing that approach, another approach, which both Richard and I have individually played around with, is creating third-party APIs. So creating an API that lives outside of your product that I could send a request to, which then sort of circumvents all of the code and just drops in a bug into my database. So then I'm not dog fooding, I've got something separate. And that could be very useful in lots of different contexts. If you're interested in that, come find me or Richard and ask us about that, because we've got lots to share about that. So that's a little bit about sort of how I structure it and sort of how I deal with some of those issues around it. But there's still more that I can get out of this created bug. I can use it to help me with the algorithm as well. At the moment, I'm now creating a bug via HTTP, but I'm still having to jump through all these different pages to get to the bug that I want. And the reason for that is that if I go to if I follow the same process as I've been doing in my check, and I go here, right. So this takes a query string. Now I could have maybe an internal counter in my framework, or that lives in a file, but that just feels very clunky and messy. And what happens if there's gaps in my creation of bugs? What if bugs get deleted? That sort of thing. Now, some of you might have noticed when I created my bug, although you didn't notice because I never actually sent the request. But if I send the request, I get a response back with an ID. So I can use that ID, drop that into my code, and immediately navigate directly to the page that I'm running my check against. And I'm going to do exactly that. So I'm going to comment out this navigate to bug, and I'm going to do driver navigate to base URL plus, and what was it again? Oops. Show underscore bug. Actually, let's just be lazy and copy that. I'm going to take that out. So I'm going to provide it a value in a second. So I go back up to my, let me just get rid of this so it's a bit clearer. So I'm going to create a shared variable, and I'm going to call it bug response payload. Like that. I'm going to go bug response payload equals this as class. And then down here, I can call that stored response and call getID. And then I just need to recreate my bug page object. Equals new driver. Nope, not. Bug page driver. There. OK, so I'm going to run that. So the important part here is that on this line here where, now once I take that request, I'm actually saying, rest assured, give me the response, which is going to come back in plain text, and I'm going to map that to my response model. And if they match, it's going to inject the values into my model, create me an object, which I can then retrieve the values from, and then retrieve that value later on to navigate straight to that page. So we're down to 8 seconds. Let me zoom in there. It's down to 8 seconds now. So we've gone from 20 down to 8 seconds. I still haven't changed the value of that check. So let's remove that. That's done. Finally, there is still some state management that we can work with. We don't need to just be thinking about how HTTP can be used to create data. We can use it to sort of manipulate data, manipulate the state of our browser. This is where HTTP and WebDriver come in harmony together in a sort of Kumbaya-based drum circle. So I want to take that state management and actually handle that via HTTP. A lot of the time, a lot of the products that we work with use cookies. And we use cookies to determine whether we're in a logged in or logged out state, and that's no different for Bugzilla. So rather than log in via the UI, what if I was to make that request via HTTP, get a response back with those cookies that I'm supposed to normally put into the browser would do automatically. If I could do a little bit of work and drop those into the browser, then when I actually carry out my check using WebDriver, the browser's already in a state of logged in. Because I've worked with a lot of architectures, and I imagine some of you have, where we have to log in and log out and switch users quite a lot of the time, and that takes up a lot of time and potentially could be flaky. So, for my final trick, I'm going to comment out the main page stuff, and I'm going to be, again, a little bit lazy, or get rid of the driver navigate. And then I'm going to copy in here, and bear with me as I sort of import everything. Yep. I feel like there should be some hold music or something, like lift music. OK, so I run that again. Zoom that in a bit better there, like that. OK, so again, I'm creating a payload, following a model, putting the username and password in, and then posting that request, that login, to my login endpoint, and that's sending me a response back which has a set cookie value in it. So I can do login.getCookie, get that value out of my response. I've then created myself a little helper. So I go in here. So I require 2 cookies to make sure that my browser is logged in. So the first one is Bugzilla login cookie, and I provide the token that's been generated. And then there's an additional one, which I don't really understand it, but there's it needs one that says Bugzilla login equals 1. So I create those 2 cookies, and then I can use driver, manage, add cookie, and they're in there. And my check is still passing. 7.5 seconds now. Get in. Cool, so those are sort of 3 demonstrations in which I've used the sacred model to help me identify problems that I'm trying to solve. And I'm thinking about those problems, and I'm thinking, what's the best way to solve them? And I feel that a lot of the time I see people working with WebDriver, they're using WebDriver incorrectly. There are other ways in which you can solve that problem, and I feel HTTP can. WebDriver is still valuable, though, because I still want to test that specific thing within the UI, so I haven't changed any of my asserts. I've just made that faster. So wrapping up, I think it's worth doing because it makes it more deterministic. There are less elements for me to look for. There are less hoops to jump through when it goes through sort of through the driver into the browser to get responses back, which means that there's less things likely to go wrong. You've just seen me increase the speed, and I promise you it's no snake oil. I never actually intended to go on about speed, but when I started running this talk, I was like, wow, I'm actually halving the time of a check. Admittedly, I'm using this on public Wi-Fi, so it's a bit more variable. But again, I don't have to think about browser DOM, page load times, receiving all the assets to create the page. I have one simple request to send them back. I'm making it more maintainable. I'm creating less code to deal with. And I'm still following those sort of dry approaches so that if I have to change something in my HTTP, I only have to change it in one place and it propagates. So I've got one last thing to say, is that some of you might think, heresy. How dare you take all that stuff out of that check? We were testing that stuff with that check. When we were entering that bug, we were actually filling those values in. If it failed, we knew that there was something broken. But did we? I think a good check should be targeted. It should tell me specifically what's gone wrong so that I can do other activities. A failed check is an invitation to explore, as Richard says to me quite often. If I have an end-to-end check that's doing all sorts of bits and pieces, it takes longer for me to determine what needs to be tested, what needs to be explored, what do I need to understand. On the flip side, though, if I remove something like that entering a bug section, I'd create another check, because there is a risk there. That's something I might not be learning about, finding information about. So I'll move that into another check, because I've just clawed myself back 15 seconds. So some recommended reading around this stuff that's influenced me. End-to-end testing considered harmful by Steve Smith. And J.B. Rainsberger has got a great talk called Integrated Tests Are a Scam, which I think are fantastic. So I'm going to just finish up by saying, if you liked what I was talking about here, please do come find me at some point. I'm around for the rest of the day, and ask me some questions if you don't want to put your hand up. But I'd just like to sort of say that I also run Software Testing Clinic, where we teach junior testers and new people to testing, and help people who are more senior to become mentors. I blog, I write about API testing. I'm an advocate for automation in testing, so I've got a lot of content on there. I work through, ministry testing provides me a platform to deliver training. At the moment, I'm doing a lot around API testing, so please check that out. And finally, I'm on Twitter at 2BitTester, number 2BitTester. That was an unfortunate Twitter name to choose, because a lot of people go for TOO, BitTester. And that's my website. So that's all that's left for me to say is thank you. And I think we've got time for a few questions. Thank you.
Excellent. Any questions for Mark? surely there has to be something.
So it means no one disagrees. Oh.
Great.
The approach, what you shared, is really interesting. I had a day-long argument with my colleague who is working with Apply tools now. I was saying you should do all the checks at UI level, but he said we should do at API as well, and you showed combination. But I think it will only work if your front-end developer are really good. They have a lot of unit test cases at JavaScript level. If they're not handling the responses back from API properly, then there may be some failures. So how confident you are going with this approach, provided the front-end developers are not writing good quality
Okay.
code?
So we're talking about here about skill sets of front-end and back-end developers, and the fact that I am kind of marrying front-end and back-end technologies together in this approach. I think that actually there's a wider question around that and a wider problem to solve, which is things like contract testing within systems. So, back-end systems writing a contract in a certain way, front-end developers using it in the wrong way, that sort of thing. So I think that there is a communication part to this. I really enjoyed Katrina's talk earlier, and I think that maybe there's an element of using something from what she was discussing to help make sure that everyone is actually communicating and collaborating together to share skills would help. Most of this stuff I've done because I'm the tester, and I'm involved in that. I'm the one that's carrying out this code base, so this is a choice I've made. I think a lot of this sort of stuff, I find that once it's created, it's done. It doesn't need to be used again. And that means that not only is it within this architecture, but if I have a pipeline of checks, my back-end developer, for example, might create all the API checks and create all those models within an architecture. But then I could potentially import that stuff. Admittedly, there's a code conflict there. There needs to be some discussion about that. But what I've done in the past is I've actually built all of the API checking stuff in its own framework, and then I've imported that as a project into the other one. So I think it's a people problem as well as a code problem. I hope that helps. Good.
I don't see any other questions, but I actually have one. Can you go back to your code?
Sure.
This might get a little bit too much into the weeds from a Java perspective.
Do I need to press? No.
Oh, yeah.
What do I need?
Chris, can we go back to the presenter slides?
Give me my slides back.
This is going to be a little bit in the weeds, Java, so I apologize. But I had a thought while we were looking at the create bug page. Great.
Yep.
What I was wondering is, could you create a bug object, which was a model of a bug that had the attributes of test product, test component testing, and you have setters on that object itself, the bug payload object.
Yeah.
And then pass that into an interface that could be either a REST implementation or a page navigation.
Yes. So in an earlier iteration, I did do that in this talk. But it got, one, I didn't feel it sold the point of interacting with algorithms very well, and two, it got a bit, I wanted to keep it simple and not complex. But things like, as well, like data builder patterns, we could drop those in and actually have it so the data builder pattern could do that for you. Yeah. So you can still keep your checks clean, but get that value out of it as well.
Cool. Well, I'm glad. I'm glad to see examples like that. It's good.
Yeah.
Separation of concerns. All right. Any other questions? Thank you, Mark.